titles are currently circulating on the web that, to understate the obvious, make us pay attention. The James Webb Telescope is said to have distinguished a brilliant carpet of artificially produced city lights on Proxima B and, in doing so, has given the answer to what is arguably the oldest question of humanity. After all, for this case, we would obviously not be alone in the universe. But what is the genuine foundation of this momentous claim? Can we already prepare ourselves to make contact with our extraterrestrial neighbors? Or are we better encouraged to treat the thrilling reports of our time with a healthy dose of wariness? When we hear the trendy term extraterrestrials, we often think of highly intelligent beings with advanced technologies that we couldn't begin to dream of. However, scientists take a somewhat different approach in their search for extraterrestrial life. It is by no means always about extraordinary beings that attempt endless interstellar journeys on board super-advanced spaceships. No, when it comes to the everyday, the quest for extraterrestrial microorganisms, bacteria, algae, and plants is just as important as the search for fully developed human civilizations. No surprise, then, that as things stand, Earth is still the only known celestial body in the universe that has developed both. Yet, if you like, we are also confronted with a homegrown mystery. We still have no clue about why and how life on our blue home planet has unfolded, and how it ultimately even managed to overcome the barrier of intelligence. For billions of years, Earth was home only to microorganisms, plants, and animals, and when it comes to the world's history, it is just a flicker of an eye. Since then, one part of life developed a species that is now capable of creating mechanical wonders like the James Webb Telescope. However, despite all the most powerful space telescopes of all time, we cannot clearly define what intelligent life essentially is, let alone whether intelligent life beyond Earth even vaguely resembles what we know in the absence of similar discoveries. Nevertheless, we still remain the only hint available to us in the quest for our unknown neighbors. The search for extraterrestrial life generally follows the theme of which factors are essential for paving the way for Earth-like life. When it comes to humanity specifically, we can probably agree that we are not friends of the dark. We have always battled the obscurity of night, first with fire and later with electric light. These days, our brilliant trails are so pronounced that they might be seen from space. While the brilliant evening sky used to release a mind-boggling exhibition of light over our ancestors, in most urban areas it can often just be glimpsed today because of light pollution. With this in mind, and assuming that other civilizations in the universe have followed a similar path to our own, the question arises as to whether there are planets out there that shine as artificially and whether we would be able to recognize this at all. Might we be able to see the city lights of extraterrestrial bodies? Luckily for us, we are not the only ones grappling with this topic. In fact, the subject of extraterrestrial technomarks is far from new in professional circles. A couple of years ago, Eliza Tabor of Stanford University and Harvard professor Avi Loeb indeed considered how feasible it would be to detect the obvious light trails of a nearby exoplanet as part of a research study. However, the master's work was not based on just any nearby exoplanet, but on Proxima B, which lies a mere 4.2 light-years away, practically right next door. It should be noted at this point that this still corresponds to a significant 37.8 trillion kilometers, and with our current means, it would take several centuries to reach Proxima B. Luckily for the two scientists, however, their hypothetical considerations did not require them to venture into the vast expanses of space themselves. Assuming this extrasolar world is actually graced by a highly developed extraterrestrial civilization with brilliantly lit cities, might we see it? Well, the sobering answer is no, in no way, shape, or form, at least not directly, because even the most powerful telescopes in history would not be able to capture the theoretical ocean of lights directly on film. At the same time, it is possible to approach the city lights of interest another way, as we can measure how much light the exoplanet reflects from its host star, Proxima Centauri. More specifically, we can predict the expected value within a certain range, and if the actual measurements exceed the hypothetical expectations, this could be due to artificial extraterrestrial lighting. What better instrument to identify this than the progressive James Webb Telescope? After all, Webb is ultimately 100 times more sensitive to electromagnetic waves than its scientific predecessor, Hubble, and in theory, it could even detect the heat of a bee on the surface of the Moon from Earth. In practice, however, Webb has been providing us with tremendous images from space for over 2 years now, and at the same time, it repeatedly reminds us of how much there is still for us to discover about the true nature of the universe. In the future, for instance, there are the incredible galaxies identified by Webb, which, with their formation dating a couple of 100 million years after the Big Bang, appear unreasonably large and massive. Some of these cosmic premature infants were already as evolved as our Milky Way is today. They have acquired the sublime moniker of universe smashers among scientists. Elsewhere, measurements by the James Webb Telescope have confirmed the so-called Hubble tension and shown that the universe is currently expanding much faster than our theories permit. Clearly, the $10 billion device has the potential to shake our established assumptions. But what has Webb currently found regarding the artificial city lights of Proxima B? Well, anything at all. It's a matter of habitability. There is one thing we must not forget. While the corresponding study by Eliza Tabor and Avi Loeb was published on May 17, 2021, the James Webb Telescope had not yet been launched into space at all. It was not launched until December 25, 2021, and it required another 6 months before the public could marvel at the first Webb images. The titles claiming that the James Webb Telescope has indeed identified artificial city lights on Proxima B are, to put it mildly, somewhat liberally interpreted. In truth, the two researchers focused only on the question of whether Webb would hypothetically be able to make such a revelation. In reality, we do not know whether life exists on Proxima B at all, let alone what technological advances it has made. What we do know, however, is that Proxima B is indeed classified as a habitable world. After all, it orbits its parent star in the habitable zone, and thus at a distance that allows for the presence of water in a permanently liquid state. Yet, the mere presence of this liquid mixture of life is not sufficient. Other factors, such as atmospheric conditions or radiation from Proxima Centauri, could still hinder the prospects of life. Nevertheless, all the favorable conditions bring us to a not unimportant point. Proxima B orbits its star at a distance of only 7 million kilometers. Therefore, it takes just over 11 days for a complete orbit, and its surface is characterized by searing heat, at least on one side. Proxima Centauri is a red dwarf that has only about 12% of the mass of the Sun. The data gathered so far suggests that Proxima B has a tidally locked rotation. On one hand, this means that it always presents the same side to its parent star. On the other hand, it results in a sharply cold night side and a significantly hotter day side. So can we throw Tabor and Loeb's study in the bin? After all, such extreme division seems to nip the possibility of potential habitability in the bud. Well, we should not be so rushed. There could indeed be a limited strip between the two zones that offers conditions suitable for life. Shockingly, the sharp contrast could even favor conditions in the so-called twilight zone. The researcher simulations have shown that the livable zone could receive its liquid water supply from the ice caps on the night side, which would melt near the terminator, feeding the lakes and rivers. When will we be able to identify the city lights of Proxima B? Up to this point, so hypothetical, but the subject of the livability of Proxima B remains fiercely debated. The doubters point out, among other things, to the violent activity of the host star. A couple of years ago, Proxima Centauri drew attention with a radiation burst that was multiple times stronger than any solar flare observed so far. Simultaneously, however, the exoplanet could have a stable magnetic field that protects it from the dangerous radiation of its host star, keeping the water molecules and oxygen on the planet. Yet, how about we assume the thrilling case that all the factors favoring life on Proxima B truly exist? Proxima B interface and an exceptionally specialized extraterrestrial civilization may actually flourish there. When would the James Webb Telescope be able to detect the artificial lighting? The research conducted by Tabor and Curve answers this question as follows. If the inhabitants of Proxima B utilize the same type of LEDs as we do, then the evening lighting there would need to be 500 times more intense than here for Webb to have any chance of detecting it. However, if the lighting intensity there is comparable to that on Earth, the extraterrestrial light would need to be emitted over a much smaller frequency range than here for there to be any chance of detection. Under these truly extraordinary circumstances, Webb could catch a brief glimpse of the extraterrestrial city lights, if they truly exist. That is a lot of subjunctives, and many scientists believe that we would be better advised in our search for life in space to consider some fresh possibilities here on Earth. In other words, just because evolution on our planet has developed eyes that can see visible light, its absence at night doesn't mean that this necessity also applies to Proxima B. Who knows? Perhaps life there has little to no sensitivity to electromagnetic frequencies in the visible range. Or maybe it doesn't have a sense of sight at all. Perhaps the inhabitants depend on sound waves or something entirely different, and there is no reason for them to turn on artificial lights at all. We simply don't know yet. Isn't it sometimes the unknown that makes exploring a subject so intriguing? To make it even more exciting, just press the like and subscribe buttons so you never miss a new video from us again. We'll see you soon.